So just wanted to point out a few of the key features of the parent functions. You'll hear me refer a lot to midline. Midline is always the point of the graph where all the points fall in the middle. So not the high point, which in this case in the parent function of sine would be at 1, not the low point, which in this case would be -1, but right in the middle. So you can see all of those points in between the high and the low points always fall at what I call the midline. So you'll hear me say that quite a bit. The other thing that we've already defined is what I call the period. The period is the time it takes to complete a full wave. So here's a full wave here. Notice I go from the middle to the high, to the middle, to low, back to middle. So it's the time it takes for me to start in the middle and hit the middle again after I've gone high and low. So there's one full period. Here's another full period. Again, notice it's the time it takes for me to start in the middle, get back to the middle after I hit a high and a low point. Now the patterns are still going to follow the same thing. Notice I always go middle, high, middle, low, middle, high, middle, low. Even if I start at this point, the pattern still follows. High, middle, low, middle, high. So it's always going to alternate. No matter where you're starting, you're alternating between the middle and a high or a middle and a low point. Cosine's very similar, except now rather than starting at the origin or starting on the midline, you're starting up at the high point. So my midline is still here, but now I'm starting high. Reason being is when you think about what these graphs are really saying. The sine graph, remember sine is the same as y, and cosine is the same as x. So if I think about the unit circle, and I'm talking about at 0 degrees, 0 degrees is straight out here, where I have a coordinate point at 1, 0. So at 1, 0, 1 is my x, which is why the cosine graph starts high, where y is 1. And here, sine is my y. That's why the sine graph starts at the middle, where y is 0. So that kind of explains a bulk of it. The key characteristics, nothing too crazy, other than just think back to regular transformations of graphs. Anytime something's on the outside, so for example, if I had y equals 4x squared, that 4 is on the outside of that quadratic function, so you're going to have a vertical stretch. We still have the same thinking here. If I multiply something by a on the outside or sine or cosine, it's stretching it vertically. That's what we call this amplitude. It's just how far up and down I move from the midline. The period is changing based on this b value. The b value is something that's happening inside a function. So for example, if we go away from sine and cosine for a second, and we have something that looks like that, what that 4 would do inside is I would have a horizontal shrink. Remember, inside stuff's always the opposite. So if you multiply something by 4, you expect it to get bigger, but this case, because it's the opposite, it actually gets smaller. So when I multiply a b value inside sine or cosine, that's going to be a horizontal stretch or a shrink. That's affecting the period, so how long it takes to complete a full wave. So anytime you're looking for the period, all you do is you take 2 pi and divide it by b. So the reason you have the 2 pi there is because 2 pi is the normal period. You want to see how b's affected the parent function's period. So period, always 2 pi over b. It's the length it takes to complete a full wave, whereas frequency is just the opposite. If you flip it upside down, that's just telling you how many waves are completed in 2 pi. So in the parent function, I complete 1 full wave in 2 pi. Whereas if I have any kind of stretch or shrink, I will usually complete more waves in 2 pi if I have a shrink. Because I'm shrinking all those waves, it's taking less time to do it. So period and frequency are very closely related. They're just reciprocals of one another.